Chapter 13, problem number 19. A synchronous satellite, which always remains above the same point on a planet's equator, is put in orbit around Jupiter to study the famous red spot. Jupiter rotates about its axis every 9.84 hours. Use the data of table 13.2 to find the altitude of the satellite.
Jupiter's in the middle here, circle. A satellite is orbiting it. What I've done is I've shown that the satellite and the great red spot on Jupiter line up. They're going to follow each other throughout the orbit, meaning that the period here is going to be the same as the rotational period of Jupiter. It will take the same amount of time for the satellite to rotate around Jupiter as it will for Jupiter to rotate. The time given in the book is 9.84 hours. We have to multiply that by 3,600 to get 35,424 seconds. In this diagram, A is the altitude. Jupiter has a radius of RJ, which happens to be 6.99 times 10 to the 7th meters. The mass of Jupiter, which is also found in the table in the book, is 1.90 times 10 to the 7th kilograms.
Sure. What's the requirement? Is it two per person?
The other we need to know is Kepler's third law. T squared equals 4 pi squared over GMP times R total cubed. R total is the distance between the satellite and the center of the object that is rotating. MP is the object that it is rotating, the mass of the object that it is rotating. In this case, the mass of Jupiter. G is a gravitational constant. First thing we want to do is plug our values into the equation. T squared is equal to 4 pi squared over G times the mass of Jupiter times RJ, which is the radius of Jupiter, plus A, which is the altitude above the surface of Jupiter, at which the satellite is orbiting. Now we have to solve for A. Multiply both sides by the inverse of the fraction. Gives you this value, or gives you this equation. Take the cube root of both sides. Subtract RJ from each side. Now, at this point, we plug our numbers in. (35424) seconds squared times G times the mass of Jupiter, 1.9 times 10 to the 27 kilograms, all over 4 pi squared. Plug it into your and then subtract, or take the cubic root of it, then subtract the radius of Jupiter, and it should give you the distance between the surface of Jupiter and the satellite.